Today we're going to be talking about section 8.1, which is estimating a population mean. A common problem in statistics is to obtain information about the mean, or mu, of a population. For example, we might want to know the mean age of all the students in a college, or the mean cost of a wedding, or the mean gas mileage of all the trucks in the country. Generally, if the population is small, we can figure out what the mean is by taking a census and then computing the mean from the population data. But usually the population is large, which means that taking a census isn't really practical. But we can get pretty accurate information about mu by taking a sample of the population. This leads us to the term point estimate, which is generally our best guess for the value of an unknown parameter based on sample data. For example, a sample mean is a point estimate of a population mean, and a sample standard deviation is a point estimate of a population standard deviation. If all the possible values of the statistic is equal to parameter, then it can be called an unbiased estimator. Otherwise, it is a biased estimator. Since this section is all about estimating population means, the point estimate that we're looking to calculate in this section is a sample mean in order to estimate the population mean. So now let's take a look at an example from MyMathLab. So in this problem, we're to estimate a population mean. We're given a simple random sample that is taken from a population, and it yields the following data for a variable of the population in this table. And now we're supposed to find a point estimate for the population mean, and which is going to be the mean of the variable. So I'm going to show you a couple of different ways to do it. The first way is we're going to do it the old-fashioned way by hand. So what we're going to do is we're going to calculate for x bar, which is equal to the sum of all the values within the table that's given, and we're going to be dividing that by the number of terms. So as we can see here, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 10 terms, so n is equal to 10. And now we're just going to sum up everything within the table. So we're going to do 9 plus 39 plus 31 plus 32 plus 19 plus 24 plus 8 plus 18 plus 19 plus 29. We're going to divide that all by 10. And what that gives us is 228, which we're going to divide by 10. And that's going to give us 22.8, which is going to be our x bar value. Now this is one way to do it. There's also going to be two other ways to do it that I'm going to show you. The first way is going to be by Microsoft Excel. So I've already opened Microsoft Excel. I've already pre-populated the values from the table into our Excel spreadsheet here. As you can see, we're taking up 10 cells within the A column here. So all we need to do is we need to find an empty cell anywhere on the spreadsheet, and we're going to go into this box and we're going to put in the equal sign so that it knows it's doing a formula. We're going to type in the word average, which is a built-in formula for Excel. We're going to use an open parentheses, and we're going to select the first cell within the column A, which is going to be A1. We're going to select a colon here to know that, so that it knows that's going to be going through the entire column. And then we're going to type in the value for the last cell of our data, which is going to be A10. So we have A10N, we're going to end it with a closed parentheses, and now we're going to hit enter. As you can see, we have the average right there, which is 22.8. which is the same as the value that we calculated by hand. And now we're taking a look at the TI Nspire app, which is TI's app version of its TI Nspire calculator. As you can see, this is under the list and spreadsheets function of the calculator, where I've already pre-populated data into the spreadsheet. So what I'm going to do now is I'm going to click on the little wrench here. I'm going to click on statistics, and now I'm going to click on stat calculations. I'm going to click on one variable statistics. I'm going to have one list, which is right there. It's going to be in my column A, and everything else looks okay. I'm going to click on OK. As you can see here, if we look at the X bar value here under cell C2, you can see that we get 22.8 as well. I know most of you had TI-84 calculators, and there's a similar function in there as well. From there, what you'd have to do is you'd have to enter the data from the table into a list, and from there you can go into the stats option and select one variable statistics, and you should be able to get all of the information that you see here in column C, including the mean, which is in cell C2. Now, usually dealing with sample means and population means, sampling error usually means that a sample mean won't be completely equal to the population mean. So we should always accompany any point estimate of mu with information that indicates the accuracy of that estimate. And this information is called the confidence interval estimate for mu. It generally provides a range of numbers along with a percentage confidence that the parameter lies within that range. And this leads us to a couple terms that we should know. The first one is confidence interval, or CI, and this is the interval of numbers obtained from the point estimate of a parameter. The second term that we should know is confidence level. This is the confidence that we have that the parameter lies in the confidence interval. The third term is confidence interval estimate. This is just basically summing up our confidence level and our confidence interval. And finally, we should know the term margin of error. And this is an indication of how accurate our guess is as an estimate of the value of the unknown parameter. So in this case, like how accurate our sample mean would be of the population mean. So now let's take a look at a problem from MyMathLab just to get a better idea of what all these different definitions mean. So if we take a look at this problem, we're given a sample mean, a sample size, and a population standard deviation, and we're asked to answer a series of questions. We can see that our population standard deviation is 3, our sample size is 64, and our sample mean is 33. And the first question asks us to find a 95% confidence interval for the population mean. So to go about solving this problem, the first thing that we should do is we need to figure out the distribution around our sample mean. So in order to do that, we need to calculate this, which is going to be our standard deviation for our population divided by the square root of our sample size. Now if we take a look at our problem here, we can see that our n is equal to 64, and our standard deviation for our population is going to be 3. So what we can do is we can plug in the numbers. We'll have 3 divided by square root of 64. Square root of 64 is going to be 3/8. From here, we want to revisit the empirical rule from chapter 6. We know that 68% of all possible observations lie within one standard deviation on either side of the mean. And 95% of all possible observations lie within 2 standard deviations of the mean, and 99.7% of all possible observations lie within 3 standard deviations of the mean. So in our case here, what we're going to do is we're going to multiply 3/8 by 2. Which gets us 3/4 or 0.75. And then we're going to add and subtract that from 33. And that's going to get us 32.25 and 33.75, which is going to be our answer for part A. And these also happen to be the endpoints of our confidence interval, which is basically defined as your point estimate plus or minus your margin of error. As we can see that our margin of error is going to be 0.75 because that's how far we are away from the mean in both directions. And from here, this comes the important part of interpreting the margin of error. What does this all mean? Because you need to be able to put your numbers into words to explain it to someone that might not be as well versed in statistics as you. So looking at different answer choices, I think choice A is the best answer choice. What we're doing is we're putting together what we have from what we're given in the problem, as well as what our answers are in part A and part B, to say that we can be 95% confident that the population mean mu is within the margin of error of the sample mean 33. And part C is asking us to express the endpoints of the confidence interval in terms of the point estimate and the margin error. So I kind of explained this concept in point A, or part A. So we can see we just have the mean here, and we're just adding and subtracting the margin of error here. So the 95% confidence interval is 33 plus or minus 0.75. That's it for section 8.1. If you have any questions, please feel free to contact the Academic Support Center for any additional help. Thank you.